Hello, this is Dr. Clyde Wilson again. This is part 2 of the Basic Introductory Nutrition mini course. I wanted to help you to understand the difference between a protein and a carbohydrate food. Essentially, things that move are mainly protein. We move, of course, cows, fish, so things that have tissue that contracts to drive movement. That those muscles that do that are made up of myosin and actin. So tons and tons of protein in those tissues that are contracting. So contractile tissue is loaded with protein, and in a restaurant we call that steak or ham or chicken or fish. That piece of contractile tissue is what was inducing movement in that animal. Animals also produce products, their offspring or products for their offspring that are high in protein. So eggs, the white is high in protein, the yolk is not, it is primarily fat. Milk is about 1/3 fat, 1/3 dairy sugar, 1/3 protein. If it's a non-fat dairy source, then it would be about half and half protein and dairy sugar. But since eggs and dairy products have as much protein as they do, you can think of them as a protein source. So in general, if it doesn't move plants, it's a carbohydrate. And if it did move, or if it's a product of something that moves, then it's a protein. Soybeans kind of straddle these two and move into the protein category because bacteria on the roots of soybeans are able to fix nitrogen from the air, combine it with the carbon and the sugars in the ground to make protein. And ruminants, cows, sheep, goats, they have bacteria in their rumen, the digestion organ, that also fixes nitrogen, just like the bacteria in the roots of the soy plant. So ruminants are able to produce protein just from eating plants, grass, as opposed to chickens and pigs, which are not ruminants, that need to have some protein in their diets so that they can accumulate protein as they're growing and maintaining their vitality. So here's a simple way of thinking about the distinction between carbohydrate foods and protein foods. If it does not move, it's a plant, then it's made out of carbohydrates. More details on that in the next lecture. If it does move, or if it's soy, then it is a protein. So we have soy, ruminants like cows, goats, and sheep, poultry and pork that's not a ruminant, so it has to eat protein, and seafood, of course. And it's either the contractile tissue from these animals that we're eating as a protein source, or their products, eggs or dairy. We can't store protein in our bodies, so roughly every 6 hours, as protein levels in the blood drop from the previous meal where there was protein, our brain will stimulate cortisol release from the adrenal glands, and that cortisol is a hormone that stimulates muscle tissue breakdown to provide protein to the rest of the body so that your more critical organs like the brain, heart, lungs, kidneys can stay viable and can flourish with a protein source. So if protein isn't coming from the intestines, from your last meal, then it's coming from your muscle tissue. The Institute of Medicine, which accumulates the scientific literature every 5 to 10 years to produce the dietary reference intakes or the recommended dietary allowances, has concluded in their review of the science that we need about 0.8 grams of protein per kilogram body weight. What they don't emphasize as much is the importance of having that protein spaced out in your day. If you don't eat breakfast, then you're not eating protein for breakfast, because there's no breakfast, and your body is eating itself. It's getting that protein from your muscle tissue. So you'll be losing muscle tissue in the range of 10 to 20 calories worth of actual contractile tissue each hour that you don't eat, and your muscle tissue is a large portion of your metabolic rate. So you will drop your metabolic rate, and instead of building and maintaining muscle mass to maintain a youthful vitality, you will be breaking down muscle mass even though you don't feel hungry. The limbic system, or emotion center in the mind, pushes out perception of hunger and pain and other things when we're trying to get to work on time, get the kids to school, we're on deadline, we have things we're thinking about, and you are much less likely to feel hungry when we wake, even though the body is eating itself in the starved state. So consistent protein through the day, which is going to come from something that moved, whether it's the contractile tissue or its products, or which is eggs or dairy, or soy. Now, whether you're using a low-fat or a high-fat dairy source, or including the egg yolks, that is a whole different topic. That's a decision you're making based on dietary fats, and is not part of the discussion of protein. Strictly speaking, the protein is the egg white, and even with a non-fat dairy source, half the calories still are not protein. So whether it's low fat, no fat, high fat, it's protein. That's the first thing to think about with regard to eggs and dairy. And then secondary to that, you can ask yourself the question, do I or do I not want the fats associated with those foods? And that will be in a later lecture. Beans, kidney beans, navy beans, black beans, are 50% as effective at building lean tissue because their amino acid ratios are different than our lean tissue. So you would need twice the amount of beans than you would expect to maintain your physiological health, which is over a cup of beans. It's a lot of beans. Peanut butter, almonds, almond milk, so nuts and seeds are also only 50% as effective at building lean tissue relative to what you'd think, and only 10% their calories are protein. If you look at the nutrition label, you'll be surprised how little protein there is in almond milk, almonds, almond butter, peanuts, peanut butter, and any other nut or seed. It would take almost 600 calories of peanut butter or almond butter to get enough protein in a single meal. Quinoa and amaranth are, unlike other grains, they're a complete protein, but it's only 10% of their calories, just like with peanut butter and almonds. So you end up needing 500 to 600 calories of quinoa and amaranth just to get 50 calories of protein. So it's the same problem as nut butters, except that the quinoa and amaranth are too high in carbohydrate to be used as a large enough protein source in your meal, and seeds and nuts are too high in healthy unsaturated fats to be really used effectively as a primary protein resource. If you've got a meal that's low in protein, sure, go ahead, use nuts or a grain that has a more complete protein, that's fine. But if you do that more than at lunch, have at least a higher quality protein source at breakfast and dinner, so you've got a good protein source every 12 hours. And then you could use the peanut butter or the quinoa as your protein source at lunch. At least you've got 2 meals around that in your day, because if you do that at breakfast or dinner, you end up going 18 hours without a good solid protein source. So my recommendation is at least every 12 hours, and then in between there you could use some of those foods that are by some thought of as a protein source that are not quite as much of a protein source as you would have originally thought.